All right, we're going to start by reviewing some factoring skills that you should have practiced kind of all year in Algebra 2, especially if you were in honors Algebra 2. So I've broken these down by types. We'll just be using these all year as well. So factor the difference of squares completely. So the pattern here is if you have a squared minus b squared, it's going to factor into a plus b times a minus b. You can confirm that by FOILing back together, distributing back together, but you get a squared minus b squared if you do that. So in this case, you're just basically saying what's the square root of each term and factoring it like that. So first one is x plus 5, x minus 5. Second one, 9x squared becomes 3x, 81 becomes 9, so 3x plus 9, 3x minus 9. Now, look at what I did on this one. It says remember to factor out the GCF first. So if you just did this and then called it a day, this is not completely factored. What we should have done first is factor a 9 out. You can take a 9 out of these two terms, then it becomes x squared minus 9. And then you can factor this difference of squares. So the 9 that I factored out is still out here, and then x plus 3, x minus 3. So this is full credit, fully factored. What if on a speed quiz you just do 3x plus 9, 3x minus 9? You don't have to erase that, but you do need to factor a 3 out of each of those terms. Oops. And then you need to simplify. So I can factor a 3 out of this 3x plus 9. I can factor a 3 out of this 3x minus 9. And all of this is being multiplied together, so 3 times 3 can become 9 times x plus 3, x minus 3. All right, so take a look at the next one. There's no GCF to take out. This is an x to the 6th. And as long as you have even exponents, that can be a difference of squares. So when you square root x to the 6th, you get x to the 3rd. And when you square root 100, you get plus 10 and x to the 3rd minus 10. We are going to talk about sum and difference of cubes, but if this number is not a perfect cube, 10 is not a number to the power of 3, then we can stop here. We're not going to keep factoring that. Okay, for the next one, this one stands out a little bit more than number 2. I can take out a greatest common factor, a GCF of 36, before I get started. So do that first. And again, if you forget, just double check your final answer when you're factoring and see if there's a common factor to take out. Now, x to the 4th minus 1 is also a difference of squares because x to the 4th is an even exponent. So the square root of x to the 4th is x squared. Square root of 1 is 1. So x squared plus 1, x squared minus 1. And then be careful. Anytime we have these higher powers, we're always checking, like, can I keep factoring this? So previously I couldn't when it was x cubed plus 10, x cubed minus 10. But here I can factor this difference of squares. There's no way to factor a sum of two squares. There's no combination of pluses and minuses to get you this. So the 36 is here to stay. The factor of x squared plus 1 is here to stay. Actually, I should side note, we are going to factor this later with imaginary numbers, but that's when we get to our quadratic section. So for speed quizzes, we'll just keep it like this. X squared minus 1 is x plus 1, x minus 1. And so we would leave this in this form. Okay, moving on to sum or difference of cubes. Again, depending on what you had last year in Algebra 2, honors, I know we hit this hard. CP, I'm not sure how much you practice this. I know you were taught this formula, but either way, we've got x cubed plus b cubed or minus b cubed. You've got a sum or a difference of cubes. You can factor that. So if it's plus, it's going to be a plus b. Those are taking the cube root of each term. And then this term will always be whatever a is squared. This is always minus a times b, or we'll usually write it as like b times a, because the a will be an x. And then plus, this is always plus b squared. Now, if this is a minus down here, then it's a minus b, a squared plus ab plus b squared. We call this the SOAP formula because, and that's to help you remember the signs. The first sign is always the same. The second sign is the opposite of what you just wrote down. and the last sign is always positive, soap. All right, so let's translate that to these problems. So still look for a GCF. There's not a greatest common factor on number 5. So the cube root of x cubed is x. The cube root of 27 is 3. So it's x plus 3. And then the formula says a squared minus ab. So x squared minus, I'm not going to write x3, I'm going to write 3x. So that's where I said it's kind of like, here's the a and here's the b. It's kind of like b times a. Last term is always positive. B squared would be 9. Now the thing about these trinomials, if you have just these trinomials after we factor, if you started with just an x cubed, this will always be prime, meaning it doesn't factor any further. You can think of all the factors of 9, but there are no combinations of factors of 9 that will add or subtract to -3. So you don't have to rack your brain over that. That's the final for this one. There's a greatest common factor here. We can factor out of 3 to begin, which is good because 3 is not a perfect cube, so we would have been stuck if we didn't do that. X cubed is a perfect cube, and 1 is a perfect cube, so we can apply our SOAP formula to this. So the cube root of x cubed is x. The cube root of 1 is 1. To get your signs, just do -1. This first sign is the same. And then it's x squared. Next sign is plus, opposite of that one. A times b, x times 1 is x, plus 1 squared is 1. For the next one, there's no common factor between 27 and 8, nothing I can factor out, but I can cube root each of those. The cube root of 27x cubed is 3x. The cube root of 8 is 2, so this is going to be 3x minus 2. And then when we square the 3x, a is 3x, b is 2, we're going to get 9x squared plus 3x times 2 is 6x. 2 squared is 4. And again, this is still prime. There's not going to be any way to factor that trinomial, so we don't have to think about that. For this next one, it's x to the 6th instead of x to the 3rd, but x to the 6th is a perfect cube. With exponents, it's a perfect cube if you can divide it by 3. It's a perfect square if you can divide it by 2. It would be a perfect power of 4 if you could divide it by 4. So the exponent. So this is can be done with a sum of cubes. So this is x squared, x to the 6th, divide the 6 by 3 to take the cube root. Cube root of 64 is 4. And then when you do squaring the first term, you get x to the 4th minus x squared times 4 is 4x squared plus 4 squared is 16. Now, does this factor any further? I know it does if this is x to the 6th minus 64. I'm not sure if this factors any further, if it's x to the 6th plus 64. We'd have to do some investigating on that. I'm not going to take the time to do it now, but maybe we'll come back to this in our polynomials chapter. For a speed quiz, I would just leave it like this. And we will look at what to do, what if it's x to the 6th minus 64 in the next couple of days. Okay, factor by grouping. Again, all of these methods should have been covered in Algebra 2. If you don't remember them, or if you really just don't remember seeing them at all, or whatever, if you struggled with them last year, come in for extra practice. These are easy to make up. Factor by grouping is when you have 4 terms, and it's basically always 2 rounds of factoring. So factor by grouping says, if possible, we want to look at the first 2 terms and the last 2 terms. We want to factor out a GCF from just the first 2 terms. So what do the first 2 terms, what factor do they have in common? We can factor out an x squared, and that would leave us with x plus 5 if we do that. And then what can we factor out of minus 4x minus 20? We could factor out plus or minus 4, but we need to factor out a minus 4 because for factor by grouping to work, you need to get the same exact parentheses when you factor out the GCF. So I factor out a -4, which just means divide by -4. You get positive x plus 5. All right, so that's the first step to factor by grouping. And then the second step, it's really just a GCF, just a complicated GCF. So we have two terms here. They both have a factor of x plus 5. So you can factor the x plus 5 out. If you factor that out of the first term, you're left with x squared. If you factor that out of the second term, you're left with minus 4. Always check factor by grouping. I love to make up factor by grouping problems that have differences of squares or maybe some are difference of cubes. So just be on the lookout for those. And the final, the final step is just to factor that. So x squared minus 4 is a difference of squares, x plus 2, x minus 2. When we have our factoring speed quizzes, they're all or nothing. They're 1 point each. So if you don't factor completely, you wouldn't get credit for that if you left it as the x squared minus 4. Okay, next one. Again, I see 4 terms, so I'm going to start by looking at the first two, the last two. What can I factor out of the first two? So I can divide both 3 and 9 by 3, x to the fourth and x cubed by x cubed. What would that leave me with? So if I divide 3x to the fourth by 3x cubed, I'm just left with x. If I divide minus 9x cubed by 3x cubed, I'm just left with minus 3. What about the last two terms? I can factor out a minus 2. It's almost always going to be whatever sign is in front of here. If you divide each term by negative 2, you get x minus 3. And so again, it should be that I have the same thing in parentheses so that I can take out that greatest common factor of x minus 3. That leaves me with 3x to the third minus 2. Now I see an x to the third, so I'm doing a quick check. Can this be a difference of cubes? And that answer is no, because I can't take anything out of 3 and 2, and neither of those numbers are perfect cubes. I guess I could apply the formula, but we're not going to factor if we don't get, if we're not getting like nice integer numbers or like fractions like a fourth or things like that to factor with. So leave it like this. Let's take a look at this one. So again, the first two terms, I know to do factor by grouping because it's 4 terms. The first two terms, I can take out an x to the third. When you divide x to the fifth by x to the third, remember that you're subtracting your exponents. So that becomes x squared minus 25. And then I almost have that, but I have kind of the exact opposite. I have negative x squared plus 25. So you can factor out a minus 1. And I like to show a minus 1 instead of just a negative sign to remind myself what I just did. Because I can factor out this x squared minus 25. It's a GCF. That would leave me with x to the third minus 1. And then again, anytime you have exponents higher than 1, you should check to see if these are special factorings. This is a difference of squares, and this is a difference of cubes. So you have to factor both of those. So the first one is x plus 5, x minus 5. The order that you write those two factors doesn't matter. If you write x minus 5, x plus 5, and then that's being multiplied by, apply the SOAP formula, x minus 1, x squared, plus x times 1 is x, plus 1 squared is 1. So this is the final fully factored answer. All right, now trinomials. I know there are a lot of different methods that we've seen to factor trinomials, so I'm just going to show you what I do. I don't do any of the like multiply by AC things. It's okay if you do. I just find that more mistakes happen with those steps. So here's what I do. Break up the first number, and this is still a bit of trial and error, but break up the first number and put your factors into these two spots. So for example, 6x squared is probably going to be 3x and 2x. Okay, and then break up the last number, put it in these two spots. The only way to break up 2 and 1 is 2 and 1. So it's either like, is it 2 and 1 or is it going to be 1 and 2? I'm just going to try this. I know it's 2 and 1. It can't be 2 and 1 here because if I had a 2x and a 2, that means I had a GCF of 2 to factor out. So you can kind of use some educated guessing here. The way to check this is, remember, what we get here should distribute or FOIL back into the original question. So you always just check the outside and the inside and see what you get when you multiply these together. So the outside gives me 3x. The inside gives me 4x. Is there any way to assign pluses and minuses with 4x and 3x to get them to add or subtract to -1? Yes, I need this to be minus, this to be plus. So I put in a minus here and a plus there. And that's it. That's the answer. I'm going to write it so it doesn't have all this writing on it. Again, I don't mind if you use, I think we call it the AC method or whatever, but what you're doing there is really just creating a factor by grouping problem. I always have to relearn that method to figure out how to help you if you're doing something incorrectly. So if you're going to be using that, it's okay, but I would like you to try it this way just to see if this makes any sense. So let's try it again. Begin by writing down your parentheses. How are you going to split up x to the fourth? With exponents, you have to split in half. It's not going to be x cubed and x or whatever. It's going to be x squared and x squared. So that's easy to split up. That's locked in. Now we just need the factors of 24 that are going to add or subtract to -2. So 24, I'm thinking 6 and 4. I need them to subtract to -2, so I make it -6 plus 4. Now, x squared minus 6. 6 is not a perfect square, so I'm not going to factor that further. We will in a later chapter, but not right now. And then x squared plus 4, there's no way to factor a sum of two squares because you'll always have a middle term or you'll have a minus here. So that's as far as that one goes. With trinomials especially, be on the lookout for GCFs. So right here, especially if your numbers are larger, take a look here. 3, 18, and 24 are all divisible by 3, so factor that out. Okay, and then it's the same thing. How do we break up x squared? X and x. What are the factors of 8 that are going to get me 6? Our only options are 4 and 2 or 1 and 8. It's got to be 4 and 2. To make this -6, they both have to be minus. Is there a GCF for 6, 5, and 4? Nope. So we're going to think, how do we split this up? Again, 6x squared, none of these numbers are huge, so it's probably not going to be 6x and 1x. It's probably going to be 3x and 2x again. And then the ways to break up 4 could either be 1 and 4 or 2 and 2. Now, I know it's not 2 and 2 because, don't write this down, but look at this. If it's 2 and 2, then I could have factored a 2 out at some point, and I can't factor a 2 out of here. So I know it's not 2 and 2. I know it's 1 and 4. And I know the 4 has to go here, and the 1 has to go here, because again, if I put the 4 here, that's a GCF of 2 I could have factored out. Then what about signs? So on the outside, you get 3x. On the inside, you get 8x. You need to get 5x. So it's got to be plus 8x minus 3x, so plus minus. All right. Now, when we're doing our factoring speed quizzes, I know that you're going for speed, so you don't have to factor it here if you're showing this work and then write it again. I'm just doing that for clarity on my worksheet. All right, and then what about these uglier GCFs? This is pretty important for calculus. I know we're in AP Pre-Calc, it's the beginning of the year, but not only am I prepping you for the AP Pre-Calc exam, but most of you are going on to take AP Calculus. So a big skill is being able to factor out these more complicated GCFs. So if you see negative exponents, if you see parentheses, rational exponents, the idea is to come up with the GCF. So we have two terms to begin with. What do these terms have in common? So 2x and 3 have no common factor, but they both have some power of x plus 2. You always factor out the smaller of the two exponents, so because you're dividing by that and you don't want to get any negative exponents. So if it helps with these weird ones, show yourself dividing by that GCF, and then what are you left with? And I like to use square braces just to distinguish for my own eyes what I'm left with and what I need to clean up. All right, so when we factor out an x plus 2 squared, we're just left with 2x from the first term. From the second term, the x plus 2 squared is going to cancel with 2 of the x plus 2's up here, but there will be one left over. So we'll have plus 3 times the quantity x plus 2. Now, I don't want you to be finished here because there could be more factoring. Also, again, for calculus, you need to keep working on this because you're going to be setting it equal to 0 or something like that. So simplify the inside of the remaining parentheses. What I mean by that is if there's distributing to do it. So this is right here, 2x plus 3x plus 6. So inside of these square braces, which I'm going to change to parentheses now, this is 5x plus 6. So that can't be factored any further, but at least I've cleaned it up. And I still have the GCF out here of x plus 2 squared. So that is the final fully factored answer. Okay, what can we take out of this? So no parentheses. There's no number in front of every x that I can factor out, but they all have x to some power. So remember, with negative numbers, negative 3 is smaller than negative 1. So we're going to factor out an x to the negative 3 because the goal is to not have any negative exponents in the final answer. So we'll rewrite that in a minute. If I divided everything by x to the negative 1, every term would still have negative exponents in it. So that is not the goal. And we don't want to have a bunch of x's in our denominator if we can help that, if we can avoid that throughout the problem. All right, so again, if you show the division, it makes things easier. So the x to the negative 3 divided by itself divides out to 1. So you're left with negative 4. Remember, we're subtracting exponents, so this becomes 3x to the negative 2 minus negative 3. That's negative 2 plus 3. So this becomes plus 3x to the first. Same thing here, x to the negative first minus negative 3 becomes negative 1 plus 3. So that becomes plus x squared. Now, if you don't like the look of this, which I don't particularly, I'm going to rearrange it. And how do we rewrite negative exponents? A negative exponent really becomes 1 over x to the third. And why is that, by the way? Here's a quick little mini proof. X to the negative third is equivalent to x to the 0 minus 3, correct? Negative 3 is 0 minus 3. If I'm subtracting in my exponent, that means I could make that x to the 0 over x to the 3. What is anything to the 0 power? 1. That's not the only way to show that proof, but that's just sort of my explanation on where that comes from. Okay, so anyway, 1 over x to the third, I'm just going to put the whole thing over x to the third. And then check this set of parentheses here. This looks like a trinomial that ought to factor. X squared gets broken up into x and x. 4 is either 2 and 2 or 4 and 1. It's got to be 4 and 1 because we want to get plus 3. So plus 4 minus 1. All of that is over x to the third. So I've gotten rid of my negative exponents, and I've factored completely. Okay, final example here. Parentheses and rational exponents, or exponents that are fractions. So the rule is still factor out the smaller of the two exponents. So 1/2 is definitely smaller than 3/2. So we're going to factor out x minus 3 to the 1/2. And again, when we say factor that out, what we really mean is divide by that term. Divide every term by that expression. So subtract your exponents. 3/2 minus 1/2 is 2/2, which is really just 1. So I'm left with x minus 3 to the first, or you could just drop the parentheses there. And then here, x minus 3 to the 1/2 divided by itself. The exponent subtract to 0 or whatever, it divides out to 1, so you just get plus 2. And like I said, I don't really need these parentheses if it's to the first power. So x minus 3 plus 2 is really just x minus 1. And this is just a rational exponent. It's not negative, so I'm not sending it to the denominator. X minus 3 to the 1/2 is still factored out there. Remember, that also means square root of x minus 3. You don't have to write it like that, but just good to know. All right, so that's sort of a crash course in all of the factoring that I'm expecting you to kind of come in with. If you need any more practice with any of these, or if you feel like some of these are really unfamiliar, please come into office hours. It just takes a little bit of practice for you to catch on.